Hi, welcome back. My name is Marty Gotzi and I'm the Principal Engineer at InSource Solutions, providers of Plat4orm. This is one of our next videos in how to use Plat4orm for your customers. Today we're going to cover the networking within Plat4orm. Within Plat4orm there are two different types of networks that can be configured for your customers. And I'll cover both of them here. Once logged into the web GUI, you can then go to network. Within network, you're going to see a couple of different items. You're going to see all of your guest networks that you have configured, as well as their CIDRs and what type of networks they are, what accounts that they belong to, as well as the name of the network. Within Plat4orm, you have two different types of routers. You have the basic built-in virtual router that comes with every account. This is a basic router that provides general port forwarding and network ACLs for one subnet. As an example, NIC1 for the account Demo1 has one of these virtual routers. If I click on NIC1, you notice that I'll get a screen that describes the network, if it's implemented and what type of network. I'll also get egress rules. The egress rules right now are configured to allow all. So basically any VM that is behind this virtual router will be able to get to the internet with no restrictions on ports. You can use the egress rules to restrict outbound ports. So as an example, if I want to restrict everything from within, from using port 25, I can do a 0000/0 CIDR, which is any subnet or any IP. Protocol is TCP. Start port is 25, end port is 25, and I can hit add. Now what this will do is any VMs that are behind this virtual router will not be able to get to the internet on port 25. This can kindly protect your network from rogue SMTP servers or any other types of functions that would use this port to send email. If I go back, you also notice that I have another location here called View IP Addresses. If I click on this, this will show me the public IP address assigned to this virtual router. If I then click on the IP, I get a little bit of information about this particular subnet or this particular IP as far as if it can be sourced and added in its ID. I can also from here under the configuration tab, I can configure the firewall and the port forwarding and the load balancing for any of the VMs hosted behind this virtual router. It works just like any other traditional router. The first thing you need to do is open the firewall port. So if I go to view all, you can see I have nothing open. Let's say that I want to allow all pings, and I want to allow this from any location. So just like before, I would do 0.0.0.0/0, indicating from a source address of anywhere. And I have the option of TCP, UDP, or ICMP. This time we're going to use ICMP. We're going to allow pings to this subnet. Hit ICMP. I'm going to allow all types, -1 or -1, and -1 is all types and all codes. So if I go ahead and bring up a command prompt, as you can see here, and I go to ping this IP address right now, 64.191.150.11, I get no reply. If I move this off the screen, and I now add this rule, it'll take it a moment to add it to the virtual router, and once it's added, it'll give you an indicator that it's been added. So now if I bring back my command window and I go to ping that IP address, it now replies. Once you have the ports open that you want to allow into this virtual router, you'd go back to the IP addresses, configuration, and then you can set up a port forward. So let's say, for example, that I would want to set up a port from all locations, TCP, port 80, and add. Once this is added, I can then go back to my virtual router settings, click on port forwarding, select the private port of 80. If it's one port, you don't have to select the end port. It will figure that on its own. Public port of 80. TCP protocol, and then I can select the VM that I want to forward this port to. Once I select this, if it has more than one IP address, it will show you this. But since this is a virtual router and not a VPC router, which we will cover in a moment, it only has one IP address. I hit apply. It will then add that to the rule set. Now, if I had a machine that was actually listening on port 80 on this IP address, I could then go to this public IP address on port 80 and it would forward that to this VM. So this is an example of a very basic firewall within Plat4orm. What you can also do as well is load balancing. So let's say, for example, that I have multiple machines and I have 2 web servers and I want to load balance those with the VMs, 2 different VMs that I have in the instance. So I'd give it a name, I'd give it a public port and a private port, so say port 80 and port 80. Select if it's round robin, least connections, or source. I would hit add VMs and select, and you notice this time though it has the VMs where you can use different IPs if it had it. Hit apply. Now I don't have the ability to do this on this account, but you can see here that it would add that to the actual virtual router. So now let's talk about the second option, which is a far more robust and fully featured router for Plat4orm. That is a VPC, or a virtual private cloud router. If I go back to network and I drop the menu down, you see I have VPC. A VPC is a more robust routing platform that allows for multiple subnets, site-to-site VPNs, network ACLs, port forward, source NATs, and it is definitely the most robust of the 2 offerings, but it does come at an additional cost. It requires at a minimum 2 public IP addresses, as well as it is an additional cost to you as the provider, since this does require additional compute power. So you can see here I have one configured, and I have a CIDR within this VPC of 172.20.0.0/21, which is going to give me about 5 to 6 or 7 to 8 VLANs I can use. If I hit configure, you notice it looks quite a bit different. It's also configured differently. The way that this works is each one of these networks is a completely separate individual subnet all on its own. Unless you allow via network ACL lists these networks to get to this network, they cannot see each other. So in essence, you can create a DMZ or an external area to where only your corp can get to, or this particular location. You do that through the ACLs. So what I'm going to do is I'm going to create a network. Notice this one is 172.20.0.0/24. So this subnet, any of the virtual machines that would be located in this particular subnet is going to be on that range. If I hit create network, and we'll call this DMZ, it's going to be an internal isolated, no load balancing. Gateway is 172.20.1.0. Actually make that 1.1. And then I want to set a subnet mask of 255.0. Notice that I have a couple of different ACL lists already created. Default allow and default deny are already there, and then you can create your own, which I'll show you in a moment. For now, I'm just going to hit default allow and hit OK. The new tier is added. So now basically I have 2 distinct subnets that I can use for port forwarding. I can put machines here and they can't see the machines here. They're completely isolated. Kindly see this as similar to VLANing within traditional networking. So if I click on network ACL list now, there's the DMZ that I created, default allow, default deny. If I click on this, you notice that it'll give me a list for ACL list rules. Click on that to drill down even further, and it shows you how it's structured. You'd give it a rule number, and it does go from top to bottom, just like a traditional list in any type of ACL platform or router. Then the action, be it allow or deny, the protocol, TCP, UDP, ICMP, all are protocol number, the port number, and then if it's an ingress or an egress rule. And then once you add this rule, then it would then be allow those ports, both be it ingress or egress, to that tier. So as an example, 172.2.0.0.0.24 allow all egress. What that means is any VM on that tier is allowed to go anywhere outside that subnet. Here, these are ingress rules. So I'm allowing from any location TCP 8443, 443, 25, 80, and 22. And this is the default rules for DMZ. So if I now go back to my router network ACL lists and then back to the internal VPC, this network ACL is applied at this edge. So if I click on this icon here, you can see that it's going to tell me if it's isolated description, and I could also scroll down and I can look at the ACL name that's applied to this. I did the default allow originally, but let's say I want to switch that. I can then click on replace ACL list, select the ACL list I want to use, hit OK, and then it will apply that ACL list. So basically what I just created with that network ACL of DMZ is now applied right at the edge of this subnet. I can have multiple lists for multiple subnets, or I can only have one list that applies to all of them. You also have to be explicit. If you want to allow communication between the 172.2.0.0 network and a 172.2.0.1 network, you have to allow that at both ACLs if they're ACL lists if they're using different lists. This is also where you would do site-to-site VPNs. A site-to-site VPN, which the VPC allows up to 8 of them, is exactly as name implies. It allows for a site-to-site VPN connection, and I'm not going to create one. Actually, I'll go into a location here in a moment that shows you some that's active. It allows site-to-site IPsec VPNs between this VPC and any other router that's running IPsec. So I'm going to log out of this account, and I'm going to log into another one which has some site-to-site VPNs active. So now if I go to network, drop this down to VPC, click on configure, site-to-site VPN. There is one site-to-site VPN. This is the IP address that it's going to, and that's the first thing you need to configure here. Once you configure that, you'll have the VPN connection. This one actually has two different connections that are being used to two different routers. So in essence, what is created here is a VPN mesh. You have this VPC router as the hub, then you have another router, a branch office at this IP address, and another branch office at this IP address that connect to this VPC router, creating in essence a hub and some spokes to connect in. Once you have this created, you would still need to go to your network ACL lists, and you still need to allow those IPs to get to the different tiers. So if I click on Corp and ACL list, you can see that I've allowed those. This is one subnet from one of those branches, and this is another subnet from another one of those branches. This will allow those particular IPsec tunnels to communicate with the tiers on this virtual private cloud. Again, you can have up to 8 of these site-to-site VPNs connected at any given time. You'll also notice that on this particular unit, I have far more IPs as well. I have 2 public IP addresses. One of them is for the router. The other one is used as a port forward for the DMZ. So if I then click into that IP address and then configuration, you notice that it looks very similar to what the virtual router looks like. But the firewall and load balancing is grayed out because those are controlled at a different location. But port forwarding is still here. So the way that this one is configured is we have the public IP address of 150.16 going to the DMZ network. Once I go into this location, I can then click configuration, port forwarding, and I can see all of the port forwards that I have set up for this particular subnet and which VM that it's going to. You You can see I have some FTPs running here as well, an OpenVPN allowing 443 and 943, and other ports here. Now if I go back to networking and I drop this down to VPN Customer Gateway, these are the two gateways that I created with my IPsec tunnels. So once you create those here, you would then go back to your VPC, configure, site to site, and you would create that connection here. And you notice that if I click on this, this is the connection. This is the phase 1 and phase 2 settings, and then this is where you would connect those. I'd like to thank you for watching today. As I continue with making these videos for my partners, I will explain in depth how to use the networking and different ways you can use the virtual router within CloudStack. Another service that we offer as well is a fully managed router outside of CloudStack. If this virtual router or even the VPC is not robust enough, we do offer a fully managed routing instance, either using pfSense or VYOS, your choice, that is running as a separate router but is tied to your instance or your customer's instance by a private VLAN to Plat4orm. This allows you to have, as an example, a fully fleshed out and fully functional pfSense router that you can use and download plugins and packages and configure as you wish. Or have as many VPNs as you wish, since there is a limitation of 8 on the VPC here. Or it just allows you to separate that routing function a little bit more and just have a more robust routing experience. I'd like to thank you for joining again today. Please stay tuned as I continue to make more videos. Next, I'll be covering storage and how snapshots are used and how to see the difference between a root disk and a data disk. Thank you very much.